This is the final episode of the E equals mc squared cubic equation series.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention. There's going to
fire.
be a short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hello.
Hello, everybody. This is my partner here, Pie Guy Pepin.
Hi.
And I'm Chemical Charlie. And we're going to talk about cubic equations today.
And now we will see the slopes. Now let's talk about the derivative with different degrees.
Okay, let's get rid of the A
The derivative.
and just have a linear equation. Well, let's begin with the most simple. Let's do it with a just a constant.
So
Okay.
then the derivative will stay at 0 since it's constant.
Right. Now let's put a linear term in. A positive linear term.
No, it's the derivative is still a constant.
And what's the value of the derivative?
Now it's 4 now.
Because this is y equals 4x plus 50, right?
So with a constant, the derivative will always equal 0. With a linear, it will equal c.
It'll equal c.
It will equal the slope.
And I'm going to make this minus 5. Now we have a negative slope.
Now we have the derivative of negative 5.
And the derivative is negative 5. All right. Now let's put in. Let's get rid of the linear term, and let's put a quadratic term in. And let's just use 2. Okay. Now this is a parabola, and the derivative is negative over here. It gets less and less negative until you reach 0. Then the slope is 0, as you can see. The orange is the slope, and then it's positive. So the derivative of a quadratic, even if you have a b term in there, is a straight line. I'm going to put a b term in. Okay, you can still see it's a straight line, all right? And it reaches 0 when it hits the minimum. But once we have a parabola, a cubic term, and let's make the c be such that it gives it a lot of shape. And now we have, you can see the derivative crosses the x-axis, has a value of 0 2 places. One where there's a maximum. At the maximum, the slope is 0. At the minimum, the slope is 0. So I think this is a very useful little program. Maybe we learn more by actually writing it. And if you actually were to write or have your students write this kind of a program, they will learn a lot. But if you want to borrow the program, I'll leave my email address, and I'll send you a copy of it if you're interested. So, all right, thank you for your attention.
And we'll see you next time.